Hello everyone. We are continuing our discussion on nanoscience and nanotechnology. Importantly, we have touched upon some of the basic and important aspects of nanoscience, where we have successfully discussed size comparison of nanostructures with bulk objects. Then we have also discussed on nanometric range and nanoscopic range, which is ideally 1 to 100 nanometers. Then we have also discussed on quantum confinement process, where we would be able to develop various variants of nanomaterials, which is called as 2D material, 1D material and 0D material, where essentially we would be able to achieve the restriction on the motion of electron in one dimension, two dimension and all three dimensions respectively. Now, in this session, particularly, we are going to focus on some of the techniques or methods by which we can make or fabricate nanomaterials. So, we will start discussing the methods to develop nanomaterials. Importantly, there are various synthesis methods to develop nanomaterials, but the elementary level classification falls into two different approaches. There are two different approaches to develop nanomaterials. One approach is called as top-down approach and the other approach is called as bottom-up approach. So in top-down approach, as here you can see that a person is breaking the bulky object into smaller parts, into smaller pieces. So that is exactly what we do in top-down approach, where initially at first place we would be having the bulk material and we are breaking that material into smaller pieces or smaller parts. Importantly, we are converting that bulky material into a nanoscopic material. That means here you can understand that initially, we would be having the dimension of material in few mm, right, and which is called as the bulky material. Now, by some of the methods, we can convert this bulky material into a material which is having the dimension which falls into 1 to 100 nanometer or in a nanometric range. So that approach is called as top-down approach. Now exactly opposite approach is called as bottom-up approach, where we start from very small scale. Small scale means from atomic or molecular scale. So what you do is you take a single atom and then you place that atom over here. Then you take another atom, then you place that second atom over here, then third atom. Likewise, you collect all atoms all together to develop a overall dimension of the object which falls in a nanometric range. So simply to create a nanostructure, we would be having collection of atoms or molecules. So here in this image, you can see that these two guys are assembling small pieces and creating a bigger objects. So in top-down approach, we break the bulk material into smaller parts. In bottom-up approach, we assemble the smaller parts to make a nanometric material or nanoscopic material. So these are the two approaches normally people follow to develop nanomaterials. Now we are going to focus on that. There are various synthesis routes or techniques to develop nanomaterials. I have only enlisted two methods. There are other than two methods as well, like biological, mechanical method, but we are not going to focus on that. We are taking interest on physical method and chemical method. So in physical method, again there are two approaches, top down approach and bottom up approach, as we earlier discussed. In top down approach, we would be having ball milling method, dry etching method, lithography. In bottom up approach, chemical vapor deposition method, physical vapor deposition method, atomic layer deposition method, pulse layer deposition method, molecular beam epitaxy, metal organic vapor phase epitaxy. So out of this all methods, we are going to focus on one method from top down approach, which is ball mill, and one method from bottom up approach, which is chemical vapor deposition. Now we will switch to next technique next title, which is chemical method, in under which also we would be having two approaches. One is top down approach and the other is bottom up approach. I have enlisted only few methods. I tell you, other than that, there are numerous methods that people follows and to create different nanostructures. So in top-down approach, chemical etching is one method, and in bottom-up approach, sol gel method or spray pyrolysis is also one method. So out of which we are going to focus on spray pyrolysis method. So all in all, our discussion would lie to discuss only three methods to develop nanomaterial. One is ball mill method, second is spray pyrolysis method, and the third method is chemical vapor deposition method. Chemical vapor deposition is sort of hybrid method where the concepts of physical method and chemical method has been used. So there are methods which falls into hybrid category where mixing of two methods can be done. Now we will start our discussion with ball mill method. So in ball mill method, simply we are crushing mechanically the bulky particles into nanostructures. It is almost the same concept where we use to convert bulk wheat into wheat powder when we visit any flour house. So the synthesis approach is top-down approach and method type is physical method. So physically we are breaking the particles or bulky particles into smaller particles. So this is the schematic of ball mill where this is the steel vessel in which we are filling up the balls by which we will crush down the particle and we will pour our powder or a material what we are having with us. So in this vessel we are keeping these balls with the material which we require to break into smaller pieces. So this is the pictorial diagram of the ball mill where these balls, which are generally of the tungsten carbide, are filled into this steel vessel and they run with a specific RPM to crush the particles into smaller pieces. To get a clear image and idea, we would be looking at one video where we will get the overall idea how the ball mill exactly works. So we are going to discuss on that. So this is the motor which is connected with a shaft and by which it is connected with a steel vessel. You can set the RPM and you would be also having the control of filling up the balls. Generally, in normal cases, this vessel is half filled with the balls, so effectively you can crush down the particles. So this is how it rotates, and this balls eventually helps us to break the bigger parts into smaller pieces. So these are some of the images which are taken of different nanostructures crushed using ball mill method, and these are SEM images of it. So here you can see various nanostructures. The scale of this image is 100 nanometers of this line. That means all the shapes, all the objects which are created which is under 100 nanometers in size. There are some of the advantages of this method, like you can have large scale operation work. So for industry purposes, normally people use this method where you can create the nanostructures more than 1 kg. It can reach up to 1 ton as well in a single shot. Less time consumption, you'd be having 1 hour run or 2 hour run, and after doing this, after 2 hours, you'll be having 1 kg or more than 1 kg nanomaterial with you. Better alloying also you can do. So mixing of the elements effectively we can do in this process. Uniformness in the particle size is there, but uniformness in the particle shape is not here. So there is one limitation of this method where we cannot have shape modulation. Although we would be having very good size modulation in this method, contamination level would be very high because this is physical method, and normally in physical methods this problem arises where physically the ball touches with your material, the inner surface of the still vessel touches to your nanostructures or to your powder. So contamination or adding of the elements, defect creation would be there in this method. Sound pollution is also case, but it can be reduced by isolation of the room. Then maintenance and replacement of the tungsten carbide balls. Because continuous use of the tungsten carbide balls, they'll collide with each other. Their surface will become rough eventually. So we need to replace the ball after some times, or we can even do surface coating of that ball as well. And there are multiple uses of that, like you can use it for ceramic compounds. Normally this method is used for the materials which are very good strength or hard materials, you can say. So these are the uses of this method. Now we are switching to next method, which is the spray pyrolysis method. The principle is that in spray pyrolysis is the aerosol process that atomizes a solution and hits the droplets to produce solid particle. We are going to discuss on this how exactly we are doing this process, but let us first understand this, the spray and pyrolysis. Spray, actually you have seen the working, the functioning of the spray. Pyrolysis, in pyrolysis the meaning of pyro is to heat. Pyro means heat. So exactly what we will do is we will take the advantage of heat and then we will solidify the material. How exactly we are doing? Let us look on it. So this method is called as bottom up approach, where we start from the atomic or molecular scale and then we reach up to nanoscopic scale. So method type is chemical method. What exactly we do is we initially make a solution which is called as spray solution. This spray solution would be containing our substance which is added into solvent. So for example, I have taken the water as a solvent. So in this solvent we are adding already prepared nanoparticles of PBS. Now this solution would be sprayed using atomizer. So atomizer exactly helps us to increase or decrease the droplet size, and from this spray nozzle we can spray the solution on this heated surface on which the substrate is placed. Substrate exactly is the surface where we want to deposit our nanoparticles. So on this substrate, which can be of glass, it can be of plastic, it can be of other materials, where we are going to deposit this PBS nanoparticle. So one layer of PBS nanoparticle will be created after depositing this. Now there are several steps which we require to follow. One step is precursor solution. So we first require to prepare a precursor solution, then a droplet transport. So according to the viscosity of the solvent and the size of the nanoparticle, you can convert the droplets. You can prepare various size drops using atomizer and spray nozzle. Now evaporation is the next step, where what exactly we do is we want this solution to be sprayed on the substrate, and afterwards the solvent what we have used, we need to evaporate that solvent because we only want these particles to be deposited on this substrate. So we heat up that surface. So for example, we have used water. So we will keep using temperature controller, we will keep the temperature of heated surface up to 150. So effectively it can heat up the substrate and evaporate the water. Then spreading. So when vapor evaporates, when water evaporates, the solid particles tries to arrange themselves into specific format. So spreading of the particle will occur. Then we can dry. Uh, After the process, after deposition, after completion of the process, we will take the substrate from here and then separately we can dry, because there are chances that some of the residues of the solvent which can be there and onto the substrate. So we can do drying and then decomposition. So there are various steps by which we can develop a proper layer of PBS nanoparticle on this substrate. Now what we will do is, again we will try to watch one video so that we can have a clear idea how exactly this works. So this is the lab scale instrument, where this is the chamber where we process. These are various interfaces. This is the gauge from where, if we want to do the process in presence of some of the gas, then also we can do. This is the heated surface and this is the heater what we're having, and from here, from this panel, we can set the temperature of this heated surface. This is the nozzle and this whole thing is atomizer, from where we can have a control over the drop size. And this is the pipe from where the solvent is coming, the solution is coming actually. So depending on the solvent what you have used, you can set the temperature. So after setting a temperature, you can just close off the door and then you start the process. So this nozzle will appropriately spray. You can have a command where you can uh, control the speed of this movement. You can have also control on some specific places if you want to deposit your material. So directly you are interfacing this instrument with a computer, so you can have all controls of atomization and specific area deposition and other things as well. So these are some of the samples which are created after spray pyrolysis method and SEM images of that. So here you can say there is comparatively we can have good shape modification modulation. These are some of the images of that. These are nanowires, which is 1D material. Now there are some advantages and disadvantages of this method as well. It is scalable method. Scalable means we can use this method for industry purposes. At industrial level also it can be used. Cost effective, range of variety, ease of preparation, safe and clean. Disadvantages are there. High level accuracy, compounding won't be possible. Compounding in during process compounding it is not possible, because from our from very beginning we are making a solution. So after making a solution we cannot do anything at this stage where we are spraying your solution onto a substrate. So during the process compounding is not possible. High temperature reaction is also a disadvantage, where we can reach up to 700 degree or 800 degree. There are some of the elements which starts functioning, which activates at 1500 degrees C. So for those materials this method won't be reliable to use. Now we will be discussing on the next method, which is called as chemical vapor deposition method. It is also abbreviated as CVD, where the vapor means the substrate on which we are depositing the substance, as we have discussed in the spray pyrolysis method as well. So the vapor is exposed to one or more volatile precursor carried by inert gas which reacts and or decompose on the substrate surface to produce the desired deposit. Now we will discuss exactly what is the meaning of this principle. But we will first discuss on the synthesis approach, which is bottom up approach. Method type, it is a hybrid method where it's a combination of physical and chemical method. Although you can write physical method or chemical method separately also. Now this is the schematic of this method where what we have is this is the reactor zone and this is the mixer zone and this is the vacuum. So there are three main components. One is the mixer, second is the reactor zone, and third is the vacuum. Vacuum means it is connected with a vacuum pump. Now what exactly happens is, let's say for example, you want to develop a compound material. So what exactly we do is we separately put various elements in here. Now at here we will initially evaporate those elements, and after evaporation the vapor of those elements will go to the mixer zone. Now this mixer zone is connected with the inert air pressure. So inert gas will come and carry the mixture of different elements from mixer zone to the reactor zone, where they'll diffuse altogether and they'll start reacting in reactor zone, and also do the compounding. Now to get a clear idea, again we will try to watch one animation. So from that animation you'll be have exact idea what exactly the chemical vapor deposition technique is. So this is the gas inlet, this is the reactor zone. So from gas inlet, various elements with the inert gas will come. So with pressure, the inert gas brings the elements, the atoms of different elements. They'll come to reactor zone and they'll start reacting with each other. Afterwards, reactor zone's temperature are of very much crucial point to discuss, but that we are not going to discuss right now. But it is having various temperature zones. So after reaction, the material will be cooled down and they'll deposit on a substrate. So here we are having a substrate, and after deposition they'll start compounding with each other. They'll rearrange themselves onto the substrate because this happens at atomic and molecular level. Now desorption of the byproducts. So this thing is connected with the reactor is connected with the pump. So at pump we are simply collecting back the other things and it is sent to the vacuum pump. So this is what the chemical vapor deposition method in brief. There are some of the advantages and disadvantages of this method. Massive production we cannot do using this. This comes into the disadvantage part. Ease of preparation, defect free nanoparticle. Compounding is very good advantage of this method. We can do compounding of almost any method, any material what we are having. Time consuming is one of the biggest disadvantage of this method because it takes from 1 day to 10 days as well to complete a process. High temperature reactions are lessly possible in this method. So these are some of the images which are created from chemical vapor deposition technique. So here you can see the development or the growth of nanostructures which is ideal. So this object is identical with this object or any other objects. So shape modulation is one of the biggest advantage of this method in comparison to ball mill method and the spray pyrolysis method. So ball mill is having very poor shape modulation. spray pyrolysis is having very at mediate, you can say, mm, lesser shape modulation, or more than the ball milling method you can have a shape modulation, and the chemical vapor deposition method would be having the best shape modulation. So these are the three methods which we have discussed so far. One is the ball mill method, second is the spray pyrolysis method, and the third is chemical vapor deposition, by which you can develop various nanomaterials. We have also discussed on the advantages, disadvantages, and the uses of method. So this is the end of this session, where we have discussed the methods to develop nanomaterials. In the next session, we will try discussing on the characterization tools, and importantly, we are going to discuss on electron microscopy and scanning electron microscope. So bye for now. In next session, we'll meet up again.